All right, so here we go, Unit 3, Objective 6. We're going to break Objective 6 into two parts. This is Part A, long division. So before we jump into long division with polynomials, let's do a quick little recap of long division with just numbers, not variables. So no polynomials yet. Let's do a little division review with just values that we learned, numbers, real numbers we learned in, I want to say third grade, or I don't know when we learned long division, third, fourth grade. So let's go ahead and practice long division with numbers. Let me autofocus here so it doesn't look weird. Give me a second so the projector can focus better here. Okay, so let's go ahead and review long division. Okay, so let's do a quick little review of long division. Let's go ahead and do, let's divide 98 divided by 7. Okay, so that's usually how you saw in elementary school, 98 divided by 7. Sometimes you see 98 divided by 7. A fraction, a ratio is also a division, right? So either way is asking us to divide. Remember what these values are called. Each one has its own name. This number 7 is called a divisor. That's the divisor. I'm always going to refer to, oh, here's our divisor. The 98 is called our dividend. Okay, it's probably those terms we forgot from a long time ago. The dividend. The answer that we're going to get is called the quotient. So I'm looking, this answer that we're going to get over here, this value, whatever it is called the quotient. Okay, so we need to be familiar with those words. This vocabulary I'm going to be using often. The dividend, the divisor, and the answer we get from the division is called the quotient. All right, so let's set up our long division. So in Brazil, I'm from Brazil, so in Brazil our teachers always said put a little ledge for your divisor, open the division box. Okay, here there's the division. See over here, it says set up a division box. Okay, in Brazil, for some reason our teacher always says set up a little ledge for your divisor. Doesn't matter if you have a ledge or not, doesn't matter to me. So here's my divisor, goes here, 7. My dividend goes inside of the division box, 98. So because 7 is just a unit, so it's just one value, I'm only going to focus on one value here. So how can I multiply some number times 7 to get a 9, or at least close to a 9? Well, we know that 1 times 7 equals 7. We know that 1 times 7 equals 7. Remember, we have to do a little subtraction right there. There was always a subtraction. Notice that the 7 is positive. It's 1 times 7 is positive 7. I want to do a little subtraction. In elementary school, some teachers also taught this idea of, let me go ahead and do a little sidebar right here. Let me move the paper. Okay. So remember, if you ever had 8 minus a 6, your teacher would say, can you rewrite it as an addition? So you can say 8 plus a negative 6 is the same answer. 8 minus 6 is 2. 8 plus a negative 6 is also 2. Okay, because you have 8 positive numbers and you're adding 6 negative numbers, and you still get a 2 positive as an answer. So adding a negative is the same thing as subtracting. So I want you to think of it that way here in long division. You may say, why? Why you're making it more complicated? I know that 9 minus 7 is 2. I know, but when it gets to polynomial, I'm going to be using this idea of distributing the negative. So it's almost like I'm saying the 7 is positive because 1 times 7 is 7. I'm going to distribute the negative to the 7, and I'm going to say 9 plus a negative 7, it's positive 2. Then we drop, there's always this dropping the next number, drop the 8. And I think, what number times 7 gives me a positive 28? I'm not thinking of negative. What number times 7 gives me a positive 28? That would be a 4. 4 times 7 gives us positive 28. And then it comes that part of subtracting. Okay, so subtracting. Like I said over here, subtracting is the same thing as adding a negative. So the 28 is positive. I'm going to distribute that negative to the 28, and I'm going to say 28 plus a negative 28 is 0. So it works. We got no remainder. Okay? There's no remainder. What does that mean when there is no remainder? What does it mean when there's no remainder? Well, it tells me that 7, the number 7, is a factor of the number 98. That 7 is a factor. As a matter of fact, the divisor 7 times the quotient 14, a factor times another factor, equals the 98. Okay? So you have a factor times another factor equals the dividend 98. Okay? Is the 7 times the 14 equals 98. So there is no remainder, so that tells me that the 7 is a factor. So that's just a quick review of dividing with numbers. Let's do it one more time. I want to do when there is a remainder. For example, okay, how about if I have 67 divided by 5? Okay, another way to show is 67 divided by 5. So we set up our little ledge, the division box. So 5 is our divisor. Our 67 is our dividend. And we're going to go ahead and do the division. So I only have one value. It's a unit 5. I'm only going to focus on one value over here. So 1 times 5 gives me a positive 5. That little subtraction, okay, is the same thing as distributing the negative to the negative 5 over here. Positive makes negative. And then I'm adding. So 6 plus a negative 5 is a 1. Then I'm going to drop that 7. There's always that drop in the next value, and I'm going to focus on that. 5 times what value gives me something close to 17? 3. 3 times 5 gives me a positive 15. Okay? And then there's the subtraction. All the subtraction I'm going to distribute over here. I'm going to make it negative, and I'm going to be saying I'm adding a negative. So 17 plus a negative 15 is a positive 2. So there is a remainder. 2 is the remainder. What does that tell me? What does it mean? Is it important to understand? Well, it tells me that 5 is not a factor of 67. Okay? 5 is not a factor. So that's the idea. If there is a remainder, it's not a factor. If there is no remainder, it is a factor. Okay? All right, now that we reviewed that with numbers only, we're going to use the same exact idea when it comes to this polynomial over here. Okay, look at the instructions. Set up the division box. Okay, so I have a binomial. I'm going to label everybody here so you know. It's saying divide using long division. Here is my dividend. This guy right here, this 4 terms polynomial is my dividend. Let me go ahead and make it bigger. Let me zoom in. Okay, so that is my dividend. This binomial of x minus 1 is our divisor. We're looking for the quotient. Because I write big, I'm going to go ahead and use a larger paper here. Okay, so I'm going to set up my little division box. You don't have to do the little edge. And then there's my division box. So x minus 1 is our divisor. It's a binomial, so let's make sure we keep it in parentheses there. Let's go ahead and set up our dividend inside of the division box. We have an x cubed minus a 3x squared plus a 8x minus a 6. Let me make my division box nice and long. Here we go. So it's nice and set up. Remember, we have a binomial. Binomials have to fit inside of binomials. Okay, I have to divide binomials to fit inside of a binomial. So I have 2 terms. I'm going to be focusing on these 2 terms right here. Okay? Forget about the rest. Eventually we'll get to it. All right? Remember that there's a subtraction. A lot of the students forget of this subtraction right here, and they start getting tangled up and making things bigger. Notice that on division, things should get smaller. Again, I'm going to refer back to my paper over here. Notice that from 67, we went down to a 17, and then down to a 2. So the numbers got smaller. If when you're dividing, it keeps getting bigger, x to the 4th, x to the 5th, well, then you're wrong, because from the 3rd, we should go down to a squared. It should go down smaller and smaller and smaller, okay? So, and the reason why you will make mistakes like that is because you forget the subtraction. All right, so I set up my division box, divisor, dividend, and that subtraction going to take place. I only focus, there's too many values, I only focus on the first, okay? What do I multiply times x to get an x cubed? That's my question. What times x gives me an x cubed? X squared, right? So let me go ahead and write x squared right above, it lines up. As a matter of fact, the second term should be the hint. X squared times x will give me my x cubed. Okay, so focus on that. But because we're multiplying times two things, a binomial, we have to multiply times both of the terms. So x squared times an x equals x cubed. That's exactly what I wanted to focus on. But then I have to continue. X squared minus a 1, x squared times a negative 1, x squared times a negative 1 is negative 1x squared. There we go. Now remember I said let's distribute the negative. So we're going to distribute the negative here. It's going to make a negative x cubed, but we have to distribute here too. So now it's going to make it a positive x squared. So I'm saying I'm adding x cubed plus a negative x cubed is 0. So that one is done. We're going to eliminate one first term at a time. Now I have a negative 3x squared plus a positive x squared. Because I distributed that negative, it became positive. So a negative 3x squared plus a positive x squared makes a negative 2x squared. There we go. That's okay. Now we are see, it became smaller. From x cubed, we made it down to x squared. Let's go ahead and it says right here, divide the terms, distribute the divisor, subtract all terms. I did that. And then carry down the remaining term. So I'm going to carry down the remaining term of positive 8x. Okay, see 2. I just need 2 because I only have a binomial. Okay. So let's set up our subtraction box right here. Don't forget the subtraction box is important. Okay, now let's just focus on this first term. What do I multiply times an x to get a negative 2x squared? That's all I focus on. What times an x is going to give me negative 2x squared? How about a negative 2x? Negative 2x times, so remember I'm multiplying negative 2x times the x squared times the negative 1. Okay? So negative 2x squared times the x gives me a negative 2x squared. I want to match exactly the same. Negative 2x times negative 1 is positive 2x. Okay, I don't care if the other one is different. I only want to make the first be exactly the same, the first terms be exactly the same. Then my distributing the negative, when I distribute this negative here, is going to make it positive. When I distribute this negative here, here is going to make it negative. Okay? So we distribute the negative. Now I can say a negative 2x squared plus a positive 2x squared is 0. I eliminate one first term at a time. I have a positive 8x plus a negative 2x, and that is a positive 6x. Okay, a positive 8 plus a negative 2 makes positive 6. Okay, now we drop the next term. We always have to drop it because we're trying to make binomial be subtracted from a binomial. So let's set up our little subtraction. Okay, let's focus on only the first term. We don't care about the second. What number times x will equal 6x? Well, that would have to be a 6, right? So plus 6 over here on our quotient. And we're going to do the same exact thing. We're going to do 6 times the x and 6 times the negative 1. Okay? So 6 times the x gives us our 6x. 6 times a negative 1 is negative 6. Notice how perfect it worked. They're exactly the same, okay? So when we distribute our negatives, when we distribute to both, this is going to become negative, this is going to become positive. And I can say that I'm adding this negative 6 and adding this positive 6. So a positive 6 plus a negative 6 is 0, and a negative 6 with a positive 6 is also 0. So plus 0, so we get a 0, okay? So this worked. There is no remainder. There's no remainder at all, okay? It worked perfect. So it's asking, is x minus 1 a factor? You say yes, it is a factor. There was no remainder. There was no remainder. That's how we know it worked. Okay. All right, let's do the next one. Nope, you know what? I want you to try it. You might have a remainder, so don't freak out if you have a remainder on this one. Okay. Make sure that there's something I should have mentioned. All powers have to exist. A 3, and then a 2, and then a 1, and then a constant. We can't skip powers. I'll explain that in the next page. Okay. So I tried the first one. I want you to try the second one. If you want to keep watching and then come back and try it for after you watch the video completely, then that's great. So let me do more practice. Let's go ahead and do the next one. So let's see. Is it going to have a remainder? Is it not going to have a remainder? Let's figure it out. So I will do the next page. All right. So we have a x cubed plus an 6x squared plus a 3x minus a 10. So we have all the powers, 3, 2, nothing here, perfect. It works. 1, 3, 2, 1, constant. And then we have the divisor of x plus 5. So let's go ahead and do it slowly. Let's go ahead and let me do it on a piece of paper here. Oh, I don't like yellow. Let me grab a white one. There we go. Okay. Just going to make it. There we go. All right. So I do a little ledge for my divisor, x plus 5. All right. So I have a x cubed plus a 6x squared plus a 3x minus a 10. Okay, good. That's our dividend and our divisor. Oop, I got to close my little parenthesis here. Perfect. All right, there's a binomial. We're going to focus on 2 terms because I can only subtract a binomial from a binomial. Okay, so they have to fit the same size. Let me set up my subtraction. Binomial with binomial right there. Okay. All right, let's focus on the first term. What value times x is going to equal x cubed? Here's the hint. It's x squared. Okay. All right. So remember, when we're multiplying, we both multiply times both of these numbers. Okay. So x squared times an x is x cubed. X squared times a 5 is positive 5x squared. So it worked out perfect. Now let's distribute the negative. Always distribute this. Distribute the negative. That's super important. So let's distribute the negative to the x cubed. It's going to become a negative x cubed. Let's distribute the negative to the plus 5. It's going to become a minus 5x. Didn't look pretty right there, but it's a minus 5x squared. Okay? Okay. So x cubed plus a negative x cubed is 0. So I'm not going to write the 0. And a 6x squared plus a negative 5x is just a 1x squared. Okay? Positive 6 minus 5 makes a just 1x squared. Let's carry down the next term, plus 3. Why don't you carry down both? Because it has to be binomial. A binomial has to fit inside of a binomial. Subtract from a binomial. Okay, let's set up our division. Our subtraction, sorry. Let's set up our subtraction. Okay, so let's focus on the first term only. X times what is going to give me x squared? Just a simple x, right? A positive, as a matter of fact. Positive x times positive x gives us a positive x squared. I'm going to make exactly be the same. A positive x times a positive 5 is plus 5x. Okay? Now go ahead and distribute the negative. This is going to become negative. This is also going to become negative. And I can say I'm adding two negative values. So x squared plus a negative x squared, that's 0. I'm not going to write it down. And a 3x, which is positive 3x, plus a negative 5x is negative 2x. Okay? Let's go ahead and carry down our negative 10. And let's set up our subtraction, which is the one that students forget about. Okay. I want to make exactly what I see here. What times this x will equal negative 2x? It's going to be a negative 2. Negative 2 times this x. Notice where I'm doing. I'm doing negative 2 times this x equals negative 2x. Negative 2 times the 5 has to be a binomial. They have to stay together the entire time. Negative 2 times 5 is negative 10. So see, they're exactly the same. So when I distribute the negative, it's going to become a plus 2x, a plus 10 when I distribute. And I can say that I'm doing a negative 2x plus a positive 2x is 0, and a negative 10 plus a positive 10 is 0. So again, that was no remainder. No remainder. Oh, it's not a question mark, it's an exclamation. No remainder. What does that mean? That means that x plus 5 is a factor of that dividend right there. It's asking right there. Is x plus 5 a factor? Yes, it is a factor. And you can say there was no remainder. Keep telling yourself that so you understand why is it a factor. Because there's no remainder. Okay, it was evenly divisible. There was nothing left over. Cool. I wonder if the next one has a remainder. So I want you to try. I'm wondering. I did 2 with no remainders. So I want you to try this one. We're going to do it in class again, but at least we're going to have some for class time. Okay. I want to do the last one because the last one has a trick that I want you to see, and that trick is going to help you on this other one over here, the example B. All right? So remember I kept saying make sure that all the powers are there. Make sure that all the powers are there. So here we go. Notice that we have an x to the 4th. And then it skips the third power, and goes down to a squared. And then it skips having just an x all the way down to a constant. We have to have all powers. For example, if I start something to the 5th, then I have to the 4th, to the 3rd, squared, to the 1st, and a constant. All powers have to be in order. Okay? If I start with something to the 7th power, 7, and then I go plus 3x squared. Well, it's missing. From 7 to 5 is missing the 6, the 5, the 4, the 3. So it's missing all these values right here. Okay? We have to have all of the exponents in order. So what happens when something's missing? We put a placeholder. We put something to hold the place of that value, okay, a placeholder. It's kind of like me saying, well, what can I put in there as a placeholder that will make no difference, okay? For example, I have 5 plus 5 equals 10. What can I add between this addition as a placeholder that will not change the result? Can I add a 1? Well, if you add a 1, it changes the result. How about if I add a 0? 5 plus 0 plus 5, does that change the result? No. So we like zeros as placeholders because it does not change the final result. That's exactly what I'm going to do. I'm going to use 0 as a placeholder for the factors, for the exponents that are missing. Okay, so here we go. Let me go ahead and write it slowly here to show you what is going on. So I have my little ledge for the binomial x plus 3 is my divisor. Okay? And I have my division box. So I have an x to the 4th. I'm missing a cubic. So I'm going to add 0x to the 3rd power. So 4, then down to a 3. Perfect. Then I can go back and write minus 7x squared. Didn't change, okay? Adding a 0 doesn't make any difference. Then I have a 4, a 3, a 2. I have to have something with an x to the first power. So let's add another placeholder for the x to the first power. And then I can come and write down my minus 18, the constant. So now we have all of the powers, a 4, a 3, a 2, a 1, and down to the constant. Okay? So we use 2 placeholders. That's okay. You can use as many placeholders as you need, as long as it's 0. Okay? There we go. We had 2 placeholders, and we'll work just fine. So I'll go ahead and finish that. Remember, we have a binomial, so we have to subtract from a binomial, 2 terms. Let me set up my subtraction. I'm going to be subtracting from these 2 terms right here. That's all I care. We only focus on the first term. What value times x is going to equal x to the 4th? Well, drop down. There's your hint, x cubed. So x cubed times an x will equal x to the 4th power. There we go. But then I have to finish it. I can't just multiply 1. X cubed times a positive 3 is positive 3x cubed. There we go. See? It fits perfectly with each other. All right, let's distribute our negative. I'm going to write it down one more time. Always distribute the negative. If you don't distribute the negative, you're going to have problems. So let's distribute our negative to this value. It's going to become negative for x to the 4th. And this one is going to become negative. So I can say I'm adding 2 negative values. So x to the 4th plus negative x to the 4th is 0. I can cross it out. I don't want to write a 0. And a 0 x cubed plus a negative 3x cubed is just negative 3x cubed. Okay, 0 plus 5, or 0 minus, think about 0 minus 3 is just negative 3. Okay? All right, let's carry down the next term, negative 7x squared. Let's set up our subtraction. Good? All right, focus on the first term right here. What number, what value times x will give us negative 3x cubed? Well, it has to be something squared, right? So let's do negative 3x squared. Negative 3x squared times an x will equal negative 3x cubed. And negative 3x squared times a positive 3 is going to give us a negative 9x squared. When you distribute the negative, this is going to become positive, and this is going to become positive. So a negative 3x cubed plus a positive 3x cubed is 0. A negative 7x squared with a positive, adding a positive 9x squared, is a 2x squared. Okay? And then we're going to carry down. Let me move my paper up. Okay. We're going to carry down that plus 0x. It will work. Let's set up our subtraction so we can distribute the negative in just a minute. Let's focus on the first term. That's all we care. What value times the x will equal 2x squared? Well, there has to be a positive 2x. Did you notice that those x are matching? Okay? All right. So 2x times x is 2x squared. 2x times a 3 is positive 6x. Make sure you distribute the negative, so this is going to become negative 2, and this is going to become negative 6. So I'm adding 2 negative values. Positive 2x squared plus negative 2x squared is 0. We're eliminating only the first terms one at a time. 0x minus 6x is negative 6x. And the last thing I need to drop down is my negative 18. Slowly, one at a time. Make sure I get all, oops, there we go. All right, let's go ahead and set our subtraction. Okay, all right. Focus on the first term, that's all you need to worry about. What value times x equals negative 6x? That would have to be a negative 6. So negative 6 times the x is negative 6x. And negative 6 times a 3, a positive 3, is Negative 18, you know it's perfect when they match exactly the same, because when you distribute the negative, they're opposites, and when you add them together, it's 0. Again, there's no remainder. I should have done one with a remainder. Sorry about that. So no remainder for the last one. So is x plus 3 a factor? Sure is. Yes. There was no remainder. Well, there is no remainder. Okay? All right, there's no remainder. There's the work. So please, please, please remember, sometimes you need placeholders. Okay? I want you to try it. Look, there's an x to the 4th, then an x cubed. The x squared is missing, so you're going to have one placeholder, 0x squared, and then there's the negative 2x plus 6. So only need one placeholder. Give it a try. You might have a remainder. I'm curious if the only 2 questions I left for you, the only 2 questions I left for you might get a remainder. Okay, so go ahead and work there, and we'll continue with part B on the next video. Okay, so part B is in the next video. All right, good luck, guys. Take care.